This is part 2 of section 3.1, which has to do with functions. If you're watching this video first, you should not watch the other video first that has the front side of the sheet. So I separated them into two because I forgot to tape the first side. So here is the second side of section 3.1, dealing more with domains and ranges and functions and all that good stuff. So example 5, the first thing it asks us is it wants us to determine whether these two guys are functions or not, okay? And this, the easiest way to do this is you can either graph those on your calculator and do the vertical line test or graph them on Desmos. But I just think about what these functions would look like, okay? So I've got an x and I've got a y squared, or y to the third power, excuse me. When I have y equals x to the third power, it looks like this. Okay, this is using like your basic algebra, remembering like what these functions look like. So x squared is a parabola, x to the third power looks like that. So if I instead have x in terms of y to the third power, what's that going to look like? What's it going to look like if you have x equals y cubed instead of y equals x cubed? Yes.
It goes the other way.
It goes the other way, Kate says. It goes the other way. So it's going to look like this. Okay? Now, is that a function or not a function? If I do the vertical line test, is it a function or not a function? Vertical line says it can only touch at one place. Yes or no? Kate, yes, it is a function. So part A, yes, it's a function. That's part A. It's still a function when it's laying on its side. Y equals x to the third power and x equals y to the third power. They are both still functions. Now part B, okay? Part B has x in terms of y squared, okay? I'm going to write out what I know y in terms of x squared looks like. You know what that looks like? What's y equals x squared look like? You guys are so smart. A parabola. So what does x equals y squared look like? Which is what we have over here. What? The other way, sideways, this way, ish. Now we don't really care about the numbers because all that's doing is like shifting this up and down and left and right or whatever. But is this one going to pass the vertical line test? No, not a function. Not a function. So that's bad, okay? I don't even care about what these other numbers mean. That's just shifting it around. Basically, I'm just looking at x's and y's and x's and y's. And that will tell me what type of function it is. Good? Yes, great. Okay, now I think tried to hammer this into your brain quite a bit. But when you have domain, when you're looking for like what x can and cannot be, there are two things that restrict a domain, or two errors like that are bad. What are dividing by 0? So I can't divide by 0. I can't have 0 in the denominator. And what else? A negative inside a square root. Those are the two main things that screw up my domain. Otherwise, if I don't have a denominator and I don't have a square root, x can literally be anything that it wants to be, with one exception. If you're dealing with story problems and it asks for like distance, what then can't it be? Negative. But aside from story problems, if you're just doing the algebra of it, you can't divide by 0 and you can't have negative inside of a square root. If you don't have a denominator and don't have a square root, then you are safe, okay? So over here, in A, I'm worried about the first error, right? I'm looking to try to see what x can and cannot be. And when you're doing that first thing, when you're talking about division by 0, these ones are really easy. You basically say x minus 1 cannot be equal to 0, okay? And then what do you do? What? You basically do the algebra of this and you add 1 to both sides, so x cannot be 1. Does that make sense? And then you are done, and that is all. So basically your domain is everything. I can plug anything I want to into this equation up here. Anything I want to, except 1. If I plug in 1, I will end up with 0 in the denominator, and I cannot have that. You made a note sheet, yeah?
Yes, he does. You're an idiot.
I don't think there's no anyway.
Okay, so B. These ones are harder. This is how you do ones for B. These ones involve a little bit more, all right? So I am dealing with a square root, and they call it u whatever. It doesn't matter. X plus 2. Doesn't matter, okay? Now, I cannot have a negative inside of here. Negatives are bad. Okay? Positive numbers are good. And at what place on the number line does it change from a negative number to a positive number? 0, right? On the number line, it changes from a negative number to a positive number at 0. So basically, I'm setting the stuff inside of here equal to 0 because I want to know where it changes from bad to good at. Okay, if I set x plus 2 equal to 0, x is equal to negative 2, right? Because at negative 2 is where it changes from a negative number to a positive number. Okay. Now, if I need to look on this number line, let's pick some points that we can plug in, like negative 3. And 0 is on this side. If I plug negative 3 in here, negative 3 plus 2, is that good or bad? Bad, because you're going to end up with a negative number. If I plug 0 in, 0 plus 2, can I take the square root of that? Yes. Just because it doesn't come out nicely doesn't mean it's like the square root of 2 is a decimal, right? But it's still okay. I can do it, right? So it's x's that are greater than negative 2. Can it be equal to negative 2? Can I do negative 2 plus 2? Can I do the square root of 0? Yes, I can. So this should be greater than or equal to negative 2. And that's what my domain is. All numbers that are greater than or equal to negative 2. And that is all. So it's a little bit more involved when you have a square root because you have to set that equal to 0 and then you have to figure out your range because it's not just something that's not equal. It's a range of values that are bigger than or less than something. But same type of deal. Okay? Same type of deal, setting it equal to 0. This one just involves one more little step. Okay? All right. I don't know what the story Paul was asking. Find the domain of a profit function. A glassware factory has fixed expenses that are $12,000 per week. In addition, it costs 80 cents to make one cup, and a cup sells for $1.95. At most, oh my gosh, 18,000 cups can be manufactured each week. Let X represent the number of cups made per week. Express the weekly revenue as a function of R. So how much money I'm making is a function of R. So we don't have to worry about the $12,000 expenses per week. That's going to be part B. So revenue, things that are making me money, is $1.95. Okay, $1.95. And then, let's see, 18,000 cups can be manufactured. So basically all that's making me revenue is the number of cups that I'm selling. And it is $1.95. How do I do that? But I don't know necessarily that I'm going to be making 18,000 cups, right? At most, I'm going to be making 18,000 cups. 1.95x. 1.95 times x. Let me look at the book and see if there's any other restrictions besides that. 18,000. I don't think they even put the 18,000 in there. No, revenue, 1.95x. Okay. And then, okay, so let's call that R equals R of x. I flip that around. R of x equals 1.95x. That's what's making me money. Okay. The next one, where they want to know my costs. So what are things that are costing me money? What? The labor, blah, 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 $12,000 and then 80 cents a cup, right? So things that are costing me money, so my cost in comparison to X is what? Yeah, 12,000 no matter what is how much it's going to cost me plus 80 cents a cup. So I'm going to do 0.8 times X. Those are my costs. Okay, now, do you know how to calculate profit? Just think about like what profit is. How do you find profit? Yeah, revenue minus cost. So basically I'm taking this equation and I'm subtracting out those. So profit of X equals the 1.95X minus this jump. Okay, find the rule for the profit. blah, blah, blah. Okay, and then let's see, 1.95x minus 12,000 minus 0.8 if I distribute the negative. So I will end up with 1.15x minus 12,000. That's going to be my equation for profit. Okay, now they want to know domain. Do I have a negative inside of a square root or division by 0? No, but I do have a story problem. Domain is talking about the x's, and x's are representing the number of cups that I'm doing, right? Okay, so what's the domain? What can I and cannot have, can I not have for number of cups? I can't have negative cups. So my number of cups has to be greater than 0. Could it be equal to 0? Yeah? So this is my domain. This is my profit equation. This is my domain. The number of cups that I make has to be either greater than or equal to 0. Yeah? Good? Okay, now, piecewise functions. Oh boy. All right. Okay, let's talk about the graph of this piecewise function. I'm going to go grab more paper. Make this graph like off to the side over here if you can. I'm just going to draw it really big so that you guys can see what I'm doing. So, graphing this piecewise function. Okay. 2x plus 3 is a linear function. How do you graph 2x plus 3? You know? Start at 3. I'm going to do a pencil. Are you guys all drawing these in pencil? Because we're going to erase some of this. Start at 3 and go up 2 over 1. Up 2 over 1 or down 2 to the left 1, blah, 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 like this. And it's going to look something like that all the way down. Okay? Whoop. Yeah, it's trying to focus on my hand. Okay, so we did positive 3, and then we did up 2 over 1, blah, blah, blah. That's what my line looks like. Now, we only want when x is less than 4. We only want when x is less than 4. X at 4 is 1, 2, 3, 4, basically all the way up here. Okay, so I'm going to stop my graph right here and only draw this side of it. Okay, I'm not going to continue going on up here. I'm not going to draw an arrow on that side because I only want when it's less than 4, right? You see that? Kinda? Okay. Now, also, it's not less than or equal to 4, so what do I need to change about that thing? You know? It's just less than, but it's not equal to, so this guy should be a open dot. Open circle. Okay, and he will stop there, all right? And then this function right here, x squared minus 1. Woo. And I want that from 4 to 10. From 4 to 10. Okay, x squared minus 1. Do you know what that looks like? What is? It's a parabola, and what's the minus 1 do? Down 1. So he looks like this. Down 1. And he's going to look, I don't know, something like this. And something like this. Okay? But we only want from 4 to 10. I should have made this a little bit bigger. I'm going to go up here. Okay? We only want from 4 to 10, so I'm going to erase this side. And I'm going to erase this side. Okay? Now, let's see where he actually touches here at 4. If I plug 4 in, 4 squared minus 1, what's that value going to be at? 4 squared minus 1. Where is that going to land me at? 16, 15? Okay, so I'm all the way up here at 15. Holy crap. All the way up here at 15. And I'm going up. Okay? What was this value at? Do you know? This was at 4 comma something. We started at 3 up 2 over 1. That's at 5, 7, 9, 11. That guy's at 11. Do you see what I'm doing? Start at 3, so we went up 2 over 1, that's at 1, up 2 over 1, 2, this is the point 2 comma 7, 3 comma 9, 4 comma 11. So here we're at 11 and here we're at 16, okay? There is a big jump in between those 2 points. This guy's going to go on for, well, no, just until we get to 10. He's going to stop at 10. Oh, this is a mess. I should have made this bigger. From 4 to 10, should probably be a bigger range, but that's okay. We don't care. From 4 to 10, this is what my piece of my parabola looks like, and then this is the other piece, okay? So he's going to stop here and he's going to jump, all right? Is he going to go forever and ever and ever and ever and ever this way? No, he's just going to stop at 10, right? Is he going to go forever and ever and ever and to the left? Yes, because there's an arrow that way, all right? So then now they're going to ask me questions about my domain. So they want to know f of negative 5. Okay, f of negative 5. Now we can plug that into this equation right here, into this piecewise function. Are you going to plug it into the top one or into the bottom one? Is negative 5 less than 4 or is it between 4 and 10? It's less than 4, so I'm going to plug that into this equation here. 2 times negative 5 plus 3 is something. Negative 7. That's what f of negative 5 is. Okay? You're not going to get 2 answers. You're only going to plug it into the equation that it works in. Okay? And then f of 8, does 8 go into the top equation or the bottom equation? The bottom, because 8 is between 4 and 10. So we do 8 squared minus 1. 63 is that value. Okay? And then the reason why we graphed this thing was so that we could figure out the domain. Okay? So my graph goes forever and ever and ever in this direction. And this one might be easier to write in the interval notation. So it's starting at negative infinity and it's going to a y or an x coordinate of 4. Should there be a bracket or a parentheses around that? Parentheses around that side. But then this guy is going from 4 on the y, or on, excuse me, on the x, to 10. Per bracket. So basically it's touching every x coordinate. I can plug in any x coordinate between negative infinity and 4. Or, excuse me, negative infinity and 10. I'm really doing a good job here. Negative infinity and 10. This will work. Any number between negative infinity and 10 I can plug in and it will spit me out something, whether it's in the top equation or the bottom equation. Now, here's where it like falls apart, okay? If I look at the range, and we've done range before of these guys, right? If I look at the range, it's going to skip over the values between 11 and 20, what was that, 15. 11 and 15. My range is only going to be from negative infinity to 11, and then from 15 to whatever, 99 maybe. This is going to be my range. They don't ask for range, but that's where it falls apart. Okay? My domain is all of the values between negative infinity and 10, but my range is going to skip over from 11 to 15. Okay? So you don't have to write your domain in 2 pieces, although we did to figure out to get to this point, right? But it's going to touch every point, because if it touches 4, if it doesn't touch 4 and then it touches 4, it's still going to be fine, right? So we can write it as one piece. But over here, the range is going to fall apart, okay? That was super confusing. I don't know, because 10 is as high as it goes, and I do 10 squared minus 1 is 99. Yeah. That's how high it goes. I didn't say that, but that's how high it goes. Whatever. Okay? Good? Something like that. You shouldn't have too many of those, I don't think. The last thing. Greatest integer function. Okay. The greatest integer function looks like this. We don't deal with this a whole lot, but this is what the greatest integer function looks like. So you have a dot, and then you have a line, and then you have an open circle, and a dot, and a line, and an open circle, and a dot, and a line, and an open circle, and a dot, and a line, and an open circle. Okay? It's what's called a step function. A step function. Okay? it goes in little steps. And the way that I think about the greatest integer function is this, okay? You guys are, anybody in here is 16? Or are you guys all 17?
Yeah.
16? You're 16? Woohoo! Okay, so 16-year-olds, all right? You are 16 years old for an entire year, right? This is on your birthday. Okay, you are 16 years old for an entire year. So if you are 16 years old in one day, you're going to say you're just 16 years old. If you're 16 years old in 3 months, you're going to say you're 16 years old. If you're 16 years old in 10 months, you're probably still going to say you're 16 years old, right? Until you get to your 17th birthday. And then you are going to jump up to 17 now, right? You're not going to go and tell people that you're 16 years old in 17 days or 16 years old in 47 days or whatever. You're just going to say, I'm 16, right? So you are 16 and you're 16 and you're 16 and you're 16 until you get to your 17th birthday, and then you jump up and you are 17 years old now. Does that make sense? Okay? Okay? So basically what happens is whatever you are, you always round down. So if you're 16 years old, if your birthday, your 17th birthday is tomorrow, you're still going to say that you're 16. You might tell people my birthday's tomorrow, but you are still 16 years old until your 17th birthday. You are always rounding down, okay? No matter how far over here you get, you are always rounding down to your 16th birthday. So each one of these numbers, when you're doing a step function, your book just does like this. They do one bracket. Sometimes a step function will be listed like this with 2 brackets. So write these down just in case you're looking at a different book. Sometimes they'll do like 2 absolute value bars. That means the greatest integer function, but always it means round everything down to the lowest value below that. So if I'm doing the lowest value, if I'm rounding negative 4.7 down, what will that become? You're rounding down. Negative 5. Okay, think of negatives. Negative 5 is lower than negative 4.7. It's hard. Negative 5, you're rounding down. What will negative 3 round down to? It will stay at negative 3, right? There's no decimal on negative 3. So that would be like on your 16th birthday. You're going to be exactly 16, okay? There's no decimals after that. What about f of 0? Stays at 0. What about f of 5/4? 5/4 is 1.25. That's going to round down to 1. And f of pi is 3.14. What's that going to round down to? 3. Everything rounds down, down, until you have your birthday, and then you jump up to the next stage. Does that make sense? That's the easiest way of explaining a step function. Because if you think about negative numbers, yeah, negative 4 would be above negative 4.5. I know, my brain doesn't work in like negatives, right? Negative 5 would be lower than negative 4.5. 4.7, does that make sense? Yeah, I know, yeah. This one is a weird one because you're in negatives, so anyway. Does that make sense? That's what step functions are used for, is like birthdays or whatever. You're doing that. That's how old you were when what? Negative point, yeah, right. Correct, exactly. Negative 0.75, But then that would round down to negative 1. So you're negative 1 years old when you're conceived. Before you. Okay, whatever. Anyway, interesting. All right, there you go. Food for thought. Whatever.